Hello, everyone, and welcome to this beautiful Tuesday, April 16th, 2024's Using GIS for State and Local Government Asset Management webinar series. Today, we're going to focus on GIS for lead line identification and safe water solutions. Hi, everyone. My name is Courtney Rowe. I work at Pape-Dawson Engineers, and I have the honor of being your MC for today's panel. We have over 150 people in today's call. Why don't we get to know you all a little bit better by bringing up a poll? So on your screen, there should be what type of organization do you work for and where are you located? And what sector do you work in? What size is your city or municipality? So this gives us a little bit of information about who we're able to touch with this very important topic. I think that GIS for lead line identification is a really pointed discussion today. We have access to more data than ever before, and the importance of having not just accurate, but also precise data for our infrastructure, especially when it comes to our health services and being able to keep our population healthy and safe. It's just really important that we focus on the integration of the right tools for the job in order to gather important information about the world around us. And then how do we share that information back with the people who need those tools in order to solve these really tough and real world problems that we have? So I hope that today you'll take away some really important information about how we're collecting data out in the field, how we're visualizing that data, and then also get that use case scenario so you can bring that information back to your community and implement it. Lead line identification can be a daunting task. So without the proper tools in your tool belt and without the collaboration, which, GIS is really all about, we definitely can't solve these problems unless we work better together. So I'm really excited today to have Alex Kabak and Gary Hoaglund and David Grafton joining us today for our panel. Let's go ahead and see who's on the call for today with these results. So wow, most of you out of almost 180 participants is from local government, and our others really are from the industry and state government, with a few in other sectors as well. Most people are joining us from the United States, but welcome to our callers from Africa and Asia. And we also have sectors in land and public administration and planning, but most of you are working in public works. And we're really hoping that this webinar showcases those tools for you to be able to bring that back and utilize them for lead line identification. Most cities and municipalities that are on the call are under 25,000 people, and a good number is between 25 and 50,000, and almost 25% of the people on the call are in populations over 100,000. Can you imagine how many people's lives this lead line identification can impact and assist as we repair our aging infrastructure? So to start today's webinar, I would like to welcome Alex Kabak, our senior product engineer from Esri. Now, Alex is also an avid sports fan, and so let's give him some great attention as he outlines for us, the Esri tools for lead line identification. Thank you, Alex.
Great, thanks, Courtney. So my name is Alex Kabak. I'm a senior product engineer for Esri's ArcGIS Solutions team. And today I'm going to be talking about the lead service line inventory ArcGIS solution. So you'll notice at the bottom right of the screen, we have a link there. That's a URL that will take you directly to the solution. That link is going to be appearing on most of the slides with the exception of the next slide. So there's no need to rush to try to write that down or take a screenshot. You'll have plenty of opportunities to see it. So an ArcGIS solution is are there maps, apps, dashboards, surveys, hub sites, data models, all pre-configured and packaged together to address industry needs. And that includes the lead service line inventory solution. So you can see the other industries we address as well. We have over 150 solutions. They're easy to deploy. It's a click of a button. If you have ArcGIS licensing, they are included. So they are free with your ArcGIS licensing. And they're also fully supported like our other products. So first I want to cover the lead and copper rules. Just a brief overview. 3 years ago, after the EPA had identified lead as being a serious health issue, they released the lead and copper rule revision that prioritized identifying and removing lead service lines. So this initial lead service line inventory is to be complete by October 16th of this year. So that's exactly 6 months from today. But it needs to be updated annually. So if you have those unknown service lines, those will continue to need to be updated. It is also required to make that inventory publicly available. And then late last year, the EPA proposed the lead and copper rule improvements. So those have not made it all the way through yet. They are still in the proposal stage. And I did highlight some of the things that might be coming down the line. I believe they want to have this in place by the end of the year. So some of those highlights would be achieving 100% lead pipe replacement within 10 years. And again, they need this inventory needs to be updated annually. Improved tap sampling. So that would be taking the first and fifth liter of a sample and taking the higher of those two samples. So that would be required, as well as lowering the lead action level. So currently there's a trigger level, which is 10 parts per billion, and there's an action level, which is 15 parts per billion. That trigger level would be going away, and the action level would be lowered to 10 parts per billion. So at that point, if you exceeded, you would need to inform your community, come out with a plan to reduce lead exposure, as well as starting the replacement process. So again, those are not completely in place yet, but they hope to have those in place by the end of the year. And best practices have emerged. So over the last 3 years, we've learned a lot, and technology has advanced to help address this need. So very quickly, a service line. If we're looking at this image right here, if you look at the circle A, that's the curb box. The utility side, so the public side, in our solution, we call it the utility side, would be anything from that water main to the curb box, and that's the utility's responsibility. And everything to the right of that curb box would be the private side. In our solution, we call it the customer side, and that would be the customer's responsibility. So again, you could see the URL to the solution on the bottom right. I'm also going to show how to get to the solution from ArcGIS Online. So we came out the lead service line inventory solution to help create those inventories, as well as manage the replacements. It's going to help to comply with regulations. You'll see in just a moment that we've actually aligned our schema with the EPA's guidelines, and also keep the public informed. So we include a hub site that will help to do that. And as I mentioned earlier, solutions are maps, apps, dashboards, etc., all pre-configured and packaged together to create a solution. And that's what we're seeing right here. These are all the different items that come with the solution. And I'm going to demo most of these in just a second. But starting at the left with the mapping technicians, there's a few different ways to add and update data. So we have an ArcGIS Pro project called Lead Service Line Inventory. And we also have a web application called Lead Service Line Editor. And a third way to add and update data would be out in the field. So we have, for mobile workers, we have a lead service line field map. Just to view the inventory, so no editing capabilities, we have the lead service line viewer. To help to manage the replacements. I want to emphasize this is not a work order replacement system by any means. It's really more to visualize where service lines have been replaced, where they're scheduled to be replaced, where they need to be replaced, and also if they don't need to be replaced. So we have the lead service line replacement manager for that. We also have a lead service line dashboard, and in that dashboard, it'll give some totals of the different lead categories that exist in your system. There's also a table included, and that table is identical to the EPA's guidelines. So back in 2022, the EPA released an Excel workbook to help. There basically was a guideline to help communities report their inventory. And so our table that's in the dashboard is exactly aligned. Every field is in the same order, and every value is there to align with the EPA's guidelines. So you can just export that and use that to copy and paste into the EPA's report. We also have for the public, I'm going to skip the next two for now, but for the public, we have the Lead Safe Community Hub site. So that's to help keep the public informed. It includes a public viewer, as well as a survey for the customers to be able to fill out the material on their side of the service line. And then to help triage those submissions from the customers, we have, going back up to the managers, the service line self-assessment manager. And then to better understand those submissions, we have the service line self-assessment dashboard. So now I'm going to jump into a brief demonstration of the solution, and then I will wrap up. So we have to find the solution. Once you're logged into ArcGIS Online or ArcGIS Enterprise, next to your login, we have the app switcher. This is how you would access different apps like Instant Apps, Survey123, Experience Builder dashboards. And then we also have the Solutions button. So when you click the Solutions button, it will take you to our list of solutions. You can use the filters on the left-hand side, but the easiest way to get to the solution would just be to type in lead. It'll be the first one listed. You can see I've already deployed it. That's what the green check mark means. When you click on the solution, you get a splash screen. You can watch a video on the different, it'd be very similar to the demo I'm about to give, just describing how to use the different applications that come with the solution. There's some images that discuss what's in the solution, as well as an overview explaining, as well as linking out to our documentation. And I highly, highly, highly recommend reading our documentation before using the solution, because there are some configuration steps, and also it describes how to use some of the different apps. After clicking deploy now, it takes about a minute or two, and it will lay down all of these items in your organization, pre-configured, ready to go. So the first app I'm going to start with is the lead service line editor. So for this demonstration, I'm not going to show the field map or the ArcGIS Pro project for the sake of time, but understand it's a very, very similar process. In those two, in the project, the Pro project and the field map, you're going to have access to all the different edit templates you see here on the left-hand side. You're also going to have access to be able to update information on existing service lines. So before showing how to use the templates on the left-hand side, I did want to talk about the symbols that you're seeing in the map. So if we look at the legend, we could see that we are using a point to represent the service lines, with the left side of the point representing the utility side and the right side of the point representing the category on the customer side of the service line. So we have 4 different categories that the EPA describes. There's lead, and we're representing that with red. There's galvanized requiring replacement, which is a galvanized pipe that is or has been at some point downstream of a lead service line. We're representing that in yellow. There's non-lead, which we're representing in blue, and unknown, which we are representing in gray. So between the two sides, there are 16 different combinations. If we look at the map, you could see dots represented on some of the service lines. Some of them have 1 dot on one side, some have both sides, and some have none. And what that dot is representing, we're actually using a label to do that, is whether or not the material has been verified on that side of the service line. So if you see a dot present on the point for a specific side, it means that that has not yet been verified. If there's no dot, that means it has been verified. So for example, looking at this dot or this point right here, the utility side has not yet been verified, which is why we have a dot on that side. The customer side has been verified, which is why we don't have a dot on that side. So to add a service line, we can use our edit template just by simply clicking an option. We can add a point to the map, and we could fill out our data. We do have a required field in here because this is required by the EPA, and that's the the status for the entire service line. So if there's lead present on the service line, you would choose a category of lead. If there's non-lead, you would choose non-lead, etc. You can also update an existing point by clicking an existing point in the map, and same idea. You would just be able to fill out or update any attributes that you need to update. For non-editing purposes, just for viewing the inventory, this is a very similar looking application. This is our lead service line viewer. And instead of edit templates, we have filters on the left-hand side. So you can view only those that have lead. You can view those that are still unverified, as well as unknown. So if you have a lot of unknowns in your system still, this is a great way to view those. We have the lead service line replacement manager. So we could see in the legend on the right-hand side, the different categories that we are representing in the map. We have doesn't need replacement in blue, needs replacement in red, scheduled replacement in yellow, and replaced in green. And we also include a filter to better understand what we are seeing in the map. So if we want to only view those that need to be replaced, it's preset to that. We can also change this to any of the categories. But now we're only seeing those service lines that need to be replaced. So either they have lead or they're galvanized and are downstream or have been downstream of lead at some point. We can use the included batch attribute editor. We can select multiple points or just one point if we need to. And we can update the status of these, the replacement status of the service line. So right now it's needs replacement. We could change that to, if we know we want to schedule it, to scheduled replacement. And we can schedule either the utility side or the customer side and provide a date. And you'll notice that the points are going to disappear from the map because we're still filtered. But now you can see they've turned to yellow triangles. So now they're scheduled to be replaced. This is the dashboard that I had mentioned. We have the totals of the different categories across the top. We also have a gauge showing how many have been verified versus the total number of service lines in the system and how many have been replaced. In the middle, you can see the table that I had mentioned earlier. At the bottom, there's a download data button to export this to a CSV, and then you can copy and paste these values, which I had mentioned are exactly aligned with the EPA's guidelines in their Excel workbook. So you can copy these values into there before reporting. We also include a map showing where lead service lines are with a list. If you click one of these, it's going to take you to it, highlight it, and you can zoom in, see the different attributes on that lead service line. To keep the public informed, we have the Lead Safe Community Hub site. On this hub site, we have the survey that I had mentioned earlier that will allow customers to submit the material on their side of the service line. I'm going to show that in just a moment. We have some statistics on just the number of lead service lines versus also the number that have been replaced. We have a public-facing lead service line inventory map. You'll notice that these symbols are different than the editor and the viewer. They are simpler to read, just using, we're not splitting the point in half. But if you do click one or use the search bar to search for an address, they'll be able to see the breakdown of the utility-owned side versus the customer-owned side, where the lead is, if there is lead, and how it was determined, how the material was determined. So you can see that with the source of data. Scrolling down, we have a section on what the community is doing to reduce lead exposure, as well as linking out to documentation on how lead affects health and what a service line is. So describing what the customer is responsible for. We've seen hundreds of examples of this hub site that have been customized. So that it's completely customizable. You can change the colors. You can add your community's symbol, update the information about where you're located, or contact information, but also just changing the text around. So we've seen so many different versions of this that have been shared with their community. This is the survey that I had mentioned that links out. So this is the, apologies, the water service line material survey. And a customer can fill this out. They can provide their information, the contact information, as well as the material on their side of the service line. We also link out to documentation to help the customer determine their material on their side of the service line and how they determined it. So did they use a lead test kit? Was it a visual inspection? etc. And then also it requires an image so that the utility can confirm what the customer is saying. To help triage those submissions, I just have some examples here of what those submissions would look like. So if we click the first one on the list, it'll zoom in on the map. We could see different information that customer submitted. So their address, their contact information, as well as the status of the submission. So we could see that it's only been submitted at this point. If we go to the next one, we could see that it's in progress. Number 2, we'll see is received, and then the last one is completed. So you can see the progress of that submission in this bar. You can see the photo that they submitted as well using the photo tab. We can also update the information. So if we have one that is now complete, it was not complete, but is now completed, we can click the pencil, scroll down to the status and change from in progress to completed. And then to help better understand these submissions, we also have a dashboard. So you can use filters at the top. We also have totals in the different categories. On the left side, we're seeing the current submissions. So if we click one of them, we could see the same pop-up that we just saw. So their contact information, the material that they submitted. So here it's copper. And then we could also see the image. The image is not aligned with the material, so just ignore that. And then on the right-hand side, same thing. We can see the pop-up. This is just for the completed submissions. So we could see the amount of time it took to complete, and the same pop-up here. So we could see that it was completed, and we could see the image that they submitted. Okay, and just to wrap up, so that was the lead service line inventory solution. Again, you could see that URL at the bottom right of the screen that takes you directly to the solution. So now I'm going to pass it on to Gary Hoaglund from Colligo GIS.
Good morning. Hi, everybody. I'd like to share my screen here with you. All right. Hope everybody can see my screen okay. And thank you, Alex, and hi, everybody. I'd just like to give a brief introduction of who we are and what we do. My name is Gary Hoaglund. I am the GIS manager at Colligo GIS and Coleman Engineering Company. We have locations in Iron Mountain, Michigan, Ironwood, Michigan, Green Bay, Wisconsin. We are GIS software developers, and since 2005, we have been a full-service GIS services provider. And our clients include small to mid-sized municipalities, utilities, organizations, tribal governments, counties, etc. And okay, to get started, I'd just like to give a brief history of some GIS challenges that we've seen many of our clients experience, and then discuss some of the solutions that were created through the use of a cloud-based GIS. And this is really geared more towards, again, the smaller mid-sized communities. Now, over the years, we've witnessed many smaller communities realize how they could benefit from GIS, but they struggled with it. And how much of their struggle was budgetary, staffing and experience to a lesser degree. Some of it was, frankly, just a hard sell to their boards, mainly for budgetary and staffing reasons, and understandably so. Now, many of these communities had staff that knew GIS, and in many cases, the staff was interested in learning more about GIS. And in many cases, this opportunity was taken advantage of, but I'll be honest, with limited success. And now this is due to the fact that many small communities have DPW or maintenance personnel, and they wear many hats and they perform many duties. So dedicating the necessary time was difficult, which some of you may relate to. Originally, though, for many of these communities, GIS was seen as a luxury back in a few years ago. And someone pursued it, but it was on a limited basis. But most of those, they just wanted a direction and a starting point. Now, the initial development was simple. Most of these communities, what they wanted was just to be able to visualize their data, see it on a map. They wanted the ability to select a line or a point and see what it represented, what information was attached to it. They wanted search and reporting capabilities, and they also wanted other simple functionality like measurement tools and such. But as time passed, the requirements of grants and reporting turned GIS into more of a necessity. And of course, the lead service line issue, this is a great example. Now, this necessity created the need for more enhancements, additional desktop capabilities, that expanded into more mobile capabilities. And this resulted into an administrative ability. And all of this resulted in the development of a desktop component. Now, what this included would be the ability to create and edit features, say point, line, polygon, unlimited attribution, and capable of performing reprojections. The ability to import and export features and attachments, to be able to import shapefiles, export shapefiles and their attachments. Users requested a change verification or quality control portion, and this was a very unique option. Now, this is where the project manager or the account manager, they can perform QC to monitor newly collected or created data prior to it being incorporated into the project. They had the ability to approve, don't approve, they can flag for further review. Those are some of the options. The end user is also able to track any geometry or attribute changes to their features, with the ability to reverse those changes if needed. And then again, the ability to attach standard photos, 360-degree photos, video attachments, PDF. They wanted data forms that could be custom built to perform asset maintenance, track maintenance history. Non-feature markup tools, the ability to create non-feature items, point, lines, polygon, SketchUp type things. This is very beneficial for project concept and brainstorming, project planning, team communication, public communications, and it ended up being smartboard capable. They also wanted custom base map incorporation of their flow and aerial imagery, for example, graphical overlays such as their georeferenced images. And as this progressed, one of the main requests that we had after was a mobile component, and this would be the second mobile component of what we're talking about. Now, it needed to work with Windows, Android, and iOS. Needed automatic online, offline syncing for mobile data collection, viewing, navigation. No prior checkout for mobile data collection. Collect data whether in coverage or not. Automatic syncing, once Wi-Fi or internet connection was restored. And again, the custom base map incorporation. And again, feature creation, editing, which again was same as desktop. Photo video attachments, the same as desktop again. And the search and navigation, and this was an interesting concept. It provides straight line as the crow flies navigation, but also turn-by-turn navigation using their road, street, center line data, their trail data, address points, points of interest. And this is very beneficial for utilities with large service areas or even emergency response. Again, custom base maps of their flow and imagery or georeference graphical overlays. Now with a desktop and a mobile, and a management component was required. And this was developed to create and manage for the project manager or account manager to create and manage assigned projects. Create, import, export data sets, perform feature styling and formatting. You can create form field classifications and attribution. Again, manage raster layers that again include aerial imagery or georeference graphical overlays. And the ability to create user access per layer, per project, per user. Who would have access to what project, what layers, and what level of access? Would this user be an account manager, project manager, mobile user, editor, view only, read only, or any combination of those depending on the project? As you can see, this development leverages a tiered system with overlapping functionalities between the desktop, mobile, and management components. And this enables an extra level of data access and management across the various devices. Now, I mention all this because it is the foundation of the end user's experience with GIS, especially when it comes to smaller communities and the lead service line replacement effort. Now, what benefit does a cloud-based GIS bring to these communities? Now, we all know that communities of all sizes have assets and resources that they need to manage. And because of this, both large and small communities equally, they have a need for GIS. Now, quite often, as an example, they'll both have to report to, say, governing bodies, funding agencies. And of course, GIS is a great help with this. And the lead service line issue, again, is a great example. However, for small communities that may have limited budgets or staffing resources, implementing GIS can be difficult. and what are the options? We have traditional GIS software. It's very advanced. It's very powerful, highly functionable, highly customizable, and along with many, many other great features. But its focus is mainly GIS professionals, larger communities, larger organizations. Now, cloud-based GIS like Colligo, now this is more for small to mid-sized communities. It provides a GIS accessibility to these smaller communities who may lack the budget or staffing resources like I just mentioned. It provides easy access to their GIS data and the ability to easily create and maintain that GIS data. And through this, our goal here is to create a larger understanding of GIS for these communities. I think our feeling is once the end users gain their experience and build those skills, they may want to investigate additional GIS options. And here are the benefits of what a cloud-based GIS provides. It provides ease of use. For those who may not have extensive GIS experience or really any GIS experience for that matter, it requires minimal initial training, minimal to no additional training, minimal technical support. Cloud-based is cost-effective. The need for the upfront investment of hardware, servers, software installation, licensing, it's greatly reduced or really just outright eliminated. It provides a dramatically reduced IT footprint, excuse me. And this is where the end user is not responsible for software upgrades, server maintenance, server replacement, has minimal or no security needs, provides disaster recovery, which we'd all like to think will never happen to us, but and it provides scalability. End users can add additional users, can reduce the number of users, easily apply or remove levels of access. And it has online, offline data collection. And this is one of the primary reasons Colligo was developed. It requires no pre-planning to work in areas where coverage doesn't exist or is unreliable. And again, it provides automatic syncing when internet connection is restored with no input required from the end user. And now that we went through that, more of the benefits of a cloud-based GIS for small communities, I'd like to get into more of the specific things and how it relates to a small community and relates out to the lead service lines. Now, recognizing the value of GIS, but lacking prior GIS experience, I'd like to present how one of our Michigan clients became fluent GIS users, and they created a comprehensive water distribution system inventory that helped them address their lead service line replacement. Now, some background on this. In 2018, the Michigan Department of Environment, Great Lakes and Energy, or EGLE as they're called, EGLE, awarded grants to tackle these water infrastructure needs across the state. And it was a pilot project that largely targeted lead service line removal in small, medium, and large communities. Now, their goal is to showcase the effectiveness of the program by having these communities complete most of their work within a single construction season. And following the project completion, EGLE surveyed the awardees in an effort to gather valuable insights for future efforts. Now, a large portion of this project was centered around GIS to create a comprehensive asset inventory. And this inventory mapped all water distribution system components that included source wells, transmission and distribution mains, water storage tank, and more crucially, service lines. Now, to do this, an accurate data collection effort was undertaken. This was a field effort. GPS data collection and mapping effort was performed by Colligo personnel and city staff, and this ensured that the accurate location of each asset for integration into the GIS platform was completed. It also had a data consolidation of information from various sources that included data from as-constructed engineering plan drawings in both digital AutoCAD and hard copies, city records, city staff knowledge, public input, relevant spreadsheets and documents, for example. And then the training of the city staff was also undertaken by Colligo personnel. Now, this project effort doubled as a practical learning experience for city staff. They received comprehensive training on the platform navigation, data collection and management, report generation. And this hands-on experience allowed them to utilize GIS and become the end users for the mapping, locating, and reporting of the water system components, specifically the lead service lines. Now, as part of that, what the results of that effort were, I'd like to go through some of this, was the results of the distribution asset inventory. And this was the major component inventory. And the information mentioned in the previous slide was collected and incorporated into GIS primarily by the city's end users, and with training and assistance from us on the Colligo side. And then here's what was determined as part of that. The water main inventory. We had nearly a little over 168 linear feet, 168,000 linear feet of ductile iron water main, a little over 133,000 of cast iron. There was almost nearly 13,000 of galvanized water main, some copper, calamine water main, I believe that's how you say that, nearly 6,000 feet of that, and that's interesting. And an unknown water main material of, nearly 57,000 linear feet. And this ended up with a total linear footage of just over 377,000 linear feet for this community. You had a public side service laterals, again, 1,550 feet of unknown public service side lateral material. There was a small amount of galvanized that they initially found. Over 1,400 feet of copper with some ductile iron, steel, brass, and plastic. And the same for the public service side laterals. Again, is very consistent with that. A little over 1,800 linear feet of an unknown material with 192 of galvanized, nearly 1,000 of copper, and again, some ductile iron, steel, brass, and plastic. I think for the public side service laterals, the unknown material would be a large consideration. I believe a galvanized material assumption would be made on this. And that would also be the case for the private side service laterals. Now, after that, other major components that were collected and incorporated into the GIS by the city end users, where I'd like to tally this. In this case, we found 531 fire hydrants, and they were given an attribution of street intersection for a location, unique hydrant ID, the manufacturer and model. In this case, I believe it's Mueller, hydrant year of 2013, condition and overall hydrant rating. What's interesting is valves. We located 1,129 valves, and they were also given a street and intersection location, unique valve ID attribution, its function and use. Was it a hydrant lead? Was it a mainline valve? Again, overall valve rating, condition. And the water shutoffs, which were critical to this effort, we were able to find 2,739 water shutoffs. Now we knew there was 290 additional that we couldn't locate, and this was due to maybe the curb box was broken, maybe it was overly buried, maybe we had some ambiguous service card lateral information from the city. And for what we found, it was also given a street and address location, the location and use, whether it was private or commercial, depth of service, whether it be 6 feet, 4 feet, 3 feet, and a condition rating. Other attribution such as criticality and a business risk, that was given mainly for like civil engineering reporting and that kind of thing. So okay, following that initial inventory of their water assets, a drinking water asset management, or DWAM, DWAM, this program was implemented to more accurately identify the material used in the community service lines. The following EVO guidelines, instead of examining every line, a statistically valid sampling approach was employed. Now this involved the vacuum excavation and inspection of 340 out of the approximate 3,000 service lines within the city. And this was done at three critical points. Ended up being inside the homes at the city meter, or in here at this diagram. Between the curb stop and the house connection, should be right here, or let's say right here, and this is the vacuum excavation, and between the curb stop and the water main. So that was all visually inspected. And now in 7 cases, the 4th inspection point was added, and this was at the connection of the point of service to the water main, and this was to check for lead goosenecks. Like the previously mentioned data collection process, this effort also served as valuable training for the city's end users. Collecting data from multiple service lines, city personnel repeated this process multiple times over and over. And that solidified their understanding of data collection and workflows. Now, as part of this project, the cloud-based platform helped the city inventory, catalog, and organize a lot of their data. And the cloud-based platform, the benefits of this were, from the end user perspective, it provided fast user onboarding. The project setup and the data incorporation is incredibly user-friendly and efficient. And the training of the city end users and the use of the mobile component, now that took about an hour. Before that was done, before the day was done, they were training additional staff. Improved data accuracy. Now, the GIS effort was initially a data creation effort, but of course, as the project progressed, it becomes more of a data maintenance effort. And the end users, they're performing this maintenance along with locating those water shutoffs not located as part of the initial efforts. And those are the water shutoffs that I previously mentioned. And this is helping them to create a more accurate and improved data set. Now, what's interesting, so the initial 340 water services that were investigated, the material of approximately 40% was found to be incorrect. And those were found to be copper, and that removed them from the replacement list. The end users, now they're the ones actively updating this data through the use of the mobile and desktop components. As services are being investigated and replaced, the end user is updating and creating additional attribution for this. This is helping to make the overall project management effort much more efficient. It produces, efficient field work. The city crews are using the mobile component to prioritize service line replacements, and this is providing greater accuracy. Before the replacement crews arrive, the end users visit individual residences. That's in an effort to confirm the service line materials. They do a visual inspection. Again, what's interesting about this is this process has identified the material of nearly 50% of the service lines initially flagged for removal. Those were found to be incorrect and were found to be copper. And this again removes them from both from the list for replacement, and that saves time and money by avoiding unnecessary replacements. Again, I'd like to stress again that with virtually no prior GIS experience, the community's end users have become proficient in updating data on the go, using the cloud-based and user-friendly desktop and mobile components. And this newfound experience translates to a long-term benefit for the entire community by providing the utility increased efficiency, better organization, and this improved decision-making is ultimately saving the city time and money. Now, just to wrap it up, I'd just like to summarize what we went over here. The cloud-based perspective. Now that provides the end user with the capabilities of powerful platform and data management. It's easy to use and easy to learn. It's accessible from anywhere. It has a greatly reduced need for hardware and software installations, IT maintenance. It's scalable. Provides fast deployment due to the reduced hardware setup and IT involvement. And all this is just one example of how we provided numerous clients with the tools and training to manage their GIS effectively. And all this while minimizing their reliance on external support. For the end user, a cloud-based platform has proven itself to be a powerful option. But ultimately, the choice between a cloud-based and a traditional GIS depends on the end user specific needs. The factors such as data size, data complexity, budget, security requirements, and staff availability and skill level. Those are all major factors that need to be given their due consideration. And now with that, I would like to turn it over to Dave Grafton. Thank you.
Thanks, Gary, for that extremely interesting overview of all of the case study stats. It's always really great seeing how these solutions are implemented and seeing just the status of what your average seed looks like as far as the lead service line inventories go. So as I said, I'm Dave Grafton. I'm a part of the Geospatial enablement team on Bad Elf GNSS hardware. That's what we do. We started with hardware. We also do services. I'll dive a little bit more into that. I'll skip a quick summary, then I'll wrap us up here for some Q&A. So, speaking of hardware, let's launch the poll right off the bat, just to see where you're at as far as GPS, what your experience is like. Definitely want to see what you all are doing on the GNSS side of things. I'll go ahead and cover where we're from, just a little more of a summary of what a lead service line inventory means, why we do it, why it's important, the method of actually creating a lead service line inventory and where we can come into play. How do you get there? And then finally, a quick overview of our hardware if you're not already familiar. So just to give a quick background, Bad Elf actually started in the aviation space. They did more before I showed up, did more handheld GPS, more recreational kind of stuff. But as the company, everyone got more and more experience. They wanted to expand their horizons, and then we expanded into the survey and GIS world, which is where I came into play. I have a GIS degree. And so that's when we introduced the Bad Elf Flex, which is our survey grade receiver. Basically, how all of our products work is that you hook it up with any phone or tablet via Bluetooth, no wires. Our app is compatible with all mobile devices. And you use that to replace your phone antenna, and you get much more accurate data and much more consistent data. So, where we're at now, the next sort of evolution of our team is the Bad Elf Geospatial Enablement Team, or GIT. We offer services in addition to our hardware to help deploy solutions like the ArcGIS led service line solution, or if you're implementing Colligo, we can help you with that. Every organization is a little bit different as far as skill level and requirements, even if there are a lot of consistent factors, set by the EPA in this case. We can help get you there, both on the office side of things and the field work side of things as well over in the field. So just give a little bit of background, a quick summary of where the lead and copper rule came from, implemented in 1991, but there's been a bunch of revisions. So it's kind of hard to keep up with all these different revisions and everything. We keep track of that. We stay on top of that so we can help update your organization if anything does happen to change. But why do we do all of this? So as many of you know, lead has many different health risks that can greatly impact the community, leads to developmental deficiencies, bit of a tongue twister there, neurological, cardiovascular impacts. In fact, the proliferation of lead, mainly from gasoline in the 70s and 80s, is often blamed for the rise in crime during the same period of time. And so by implementing these lead service like guidelines, the copper rule regulations, the whole country saves billions and billions of dollars in health and infrastructure damages each year. And it's been shown to reduce crime rates as well, as I mentioned. So how do we maintain compliance? A lot of you here are part of small governments. Thanks for filling out that poll. The local government compliance challenges can include limited resources, evolving regulations. As I said, you might have staff who are familiar with some regulations in the past, but often, there could be turnover. You might be training new hire, and the regulations and the system you're using for your system of record obviously evolves over time. I mean, basically all organizations started with paper maps. ArcGIS, unfortunately, wasn't a thing when this was first really implemented in the early 90s, for the most part, for most smaller governments at the very least. So all of this is evolving over time. There's 9.2 million lead pipes out there, plus, obviously more are being identified, and it can be tough to keep up with. So it's really important that you have a consistent, easy to follow workflow that can be picked up from one staff member to the other. Because if you offer too many roadblocks, then it can be tough to track your data, maintain that system of record, and then we start running into fines, some legal issues, obviously health risks, but the financial implications for your organization can be quite severe. So that's why just implementing and maintaining a good GIS solution is vitally important. All right, so where does Bad Elf mainly come into play? So GNSS field collection. So the EPA does require a location tracking for all of your lead service line identifications. However, a lot of the times it just requires address. But however, if you're actually trying to share this data with the public, you're going to want GPS coordinates. It helps with identifying where the lead lines are, tracking them, and if service crews have to go out and identify where they are, having the most accurate data is important. So phones and tablets are often used for this task. However, they just simply aren't that accurate. If you look at the picture in the bottom left over here, you can see the point is where the phone's going to place the point, but that may actually land anywhere within those circles. It's basically how accuracy works. It's a radius of uncertainty of where your point is placed in relation to where the actual feature exists. So these phones and tablets, they have, they could have nice, processing engines and everything, but at the end of the day, the antennas aren't just dedicated for the task of receiving satellite signal all the way out from space and placing them in an area the size of your phone or tablet itself, like our receivers do. Just phones are simply designed for too many different things to be able to do that effectively. So that's why we create dedicated GPSs. Our primary two are the Bad Elf Flex, our survey grade unit, and our Bad Elf Flex Mini, which is also quite accurate, but it's a little bit smaller, just slightly less accurate. And it actually can attach to any phone, tablet, etc., for maximum portability. So this will give you much more accuracy and consistency as well. You're not dealing with different hardware specs and different phone versions and everything. You're going to get the same metadata and the same accuracy each time. Obviously, with some considerations, you are always dealing with some sources of error. The closer you are to a building, you're just going to start dealing with multi-path error where GPS signals bounce off buildings and whatnot. So with a phone, you might be seeing 50+ foot accuracy. Your point might be placed in a whole different address, whole different yard. But with Bad Elf GPS, we can go ahead and mitigate that as much as possible and give you those accurate coordinates to include into your solution. So just give a quick component overview. Obviously, Alex has covered this a lot, as well as Gary. You have to implement your existing records into your system, identify materials, and most of all, for us at least, have a location. So you can't replace them if you don't know where they are, so you have to have that location associated with your records. So how the actual field process goes, it's basically a 5-step process. We start by planning and coordinating field crews. This can be done with ArcGIS Workforce as well as other applications out there to go ahead and begin to navigate to the place where the lead service lines have to be inspected and or replaced. We have to the field crews, once they get there, they have to understand where these lead service lines are. If when you're initially creating your system, might be a little bit difficult, but if you use accurate GPS receiver along with an easy to understand system such as Colligo or ArcGIS solutions, they'll be able to identify exactly where that lead service line is and all the information about it from the pop-up and the attributes associated with that record. Finally, you'll capture your updated data, either the location of the line, or you might just be updating the status of the line as well with pictures and updating the attributes. And finally, you can monitor all of this through web maps, web apps, and dashboards and whatnot. Keep track of how your replacement is going, as well as sharing all that information with the public. So digital asset mapping benefits, probably the number one I just mentioned is just a real-time understanding of where all the locations as well as the status of these lead service lines are. Instead of having to interpret a paper map, you get to use your high accuracy GPS, know exactly where it is located in relation to you, as well as giving the public real-time access to data, as well as decision makers and whatnot. to track how the replacement is going. All right, I'm gonna skip through here a little bit. We're running out of time. Just wanted to mention that we, again, we're not just hardware anymore. We are evolving the geospatial enablement team to offer services. Again, every organization is a little bit different. Everyone's going to have different skill levels, different needs, both through the field workers as well as the office workers. So with all of our experience, with me, Dr. Nick Smolovsky, Noah Galenko, Chris Zuniga, we've have years of experience combined and can really help you get across the finish line as far as implementing the solution and training your whole team and get you up and running. I think that's really the key, is just this matter of really getting the ball rolling. That way you can really minimize any errors, discrepancies in your data, and maintain metadata, especially as a lot of GPS as the GPS world is evolving very quickly with improved technology. With our Battleflex Mini, you can get sub-foot accuracy in the palm of your hand, as well as all the new datums and everything coming out as well, new projection systems. We're all experts on that front, so we can definitely help you manage that and mitigate any issues. If you want to scan the QR code right here, you get a bit more information on what we do as far as consulting packages, solution implementation, as well as hardware training implementation. That'll take you to our website, and you can check that out. And here's the two receivers I was mentioning. We have our survey grade Battleflex, as well as our handheld Battleflex Mini over here, especially for lead line service inventories. We're really excited about the Mini. Again, it attaches to any phone or tablet, and you can connect to a local RTK network to get sub-foot accuracy and really just maximize the power of your solution and your data. So, all right. So yeah, appreciate everyone for attending, sticking around to the end, and I will pass it back to Courtney and the rest of the presenters for Q&A.
Thank you so much, David. And thank you to all of our panelists today. What informative projects and solutions we have here for everybody to access. So I'd like to invite all of our panelists to come back and answer this question submitted on the Q&A by Saban. What are some of the challenges that cities frequently have in rolling out lead line solutions? I think each and every panelist can have a unique answer to this one.
Yeah, I can start from the Esri point of view. The question we get the most is, how do you get your data into the solution if you already have existing data? So that we do have some advice on that we have documentation on that as well, because data does come in all different formats. Some of it's some of our users' fields may not align with our fields. So we do have tools that help with that. We have something called the data loading tools that will allow you to do some ETL. So it'll allow you to map your source to target fields, but also map your source domain values to the target domain values as well. So if you have integer fields and we have text fields, it will convert those integers to text for you. So we do have that in ArcGIS Pro. They're called the data loading tools.
Gary, what about you?
Sorry, may have a quick answer for that. Also, I agree with Alex. I mean, I think the biggest challenge is getting the existing data in there. And from what I can tell, from a smaller community standpoint, which is what our primary focus is, I mean, it ranges from you may have plan rooms that have a lot of maps in there. There may be some AutoCAD, different as-built kind of thing. And some communities they have very good records that we've worked with, and it's quite simple. So I think the best thing to do is, the biggest challenge is getting the information compiled into a GIS to be able to help them make get direction, get it organized, help them to make the decisions on where to go and how to proceed.
Yeah, I just wanted to speak on it a bit from a field worker's perspective as well. Obviously, that's a big part of the equation. I think one of the key components is, finding a good champion, someone, real excited, high energy about start using, GIS in the field. And that way they can really set a good example. I think people feel a lot more comfortable when they're with colleagues and when they, have lunch with, grab a beer with, is really just promoting the solution, the product, and they can help. Obviously, with us, we do provide consulting and training and everything, but beyond that, once we go, it's really great to have someone there to answer questions, give their experience, and provide suggestions on best practices, standard operating procedures, and whatnot.
Excellent answers. Thank you, everybody. And thank you, Alex, for expanding for Megan's question on how to add those existing data fields that might not match up. So he's already integrated that answer. Let's see. Alex, if you could share some documentation related to that question about those matching fields and how ArcPro handled that, that would be great. And what about looking for a mapping software in addition to an LC, I guess, or location survey? And could this mapping be ongoing after the survey is completed? Alex, I saw when you were doing your demonstration, you showed some in progress points as well. So from my perspective and knowing some of the background of ongoing surveys in the field and ongoing mapping in the office, I can definitely see this as an ongoing process and an editable process. What about from y'all's perspective?
Yeah, absolutely. Especially the EPA is going to require an annual update. So this is going to continue to have to be updated every year. You may learn some new things out in the field that you want to continue to update. You may get submissions from customers and customers letting you know their the material on their side of the service line. So that's going to continue to be updated as well. So it's definitely an ongoing process.
So Nader had said that they're looking into putting some asset management system in place to keep track of all of the assets for a city about 30,000 people. I'm seeing the Esri's Leadline Solutions product as a possibility for them. Does anybody else have some suggestions about how they can improve their GIS asset management?
I would
Gary?
agree. Yeah, the Esri solution is really robust, especially for a city. We get into 30,000 population or greater, we may have the resources to apply that kind of platform. There is also some other, on the Colligo side, we have some data asset management type processes also that come into play. The data forms, tracking history, that kind of thing of data management is also available.
So how have y'all mitigated or worked with surveyors who may have a scale factor for their data collections and to bring those assets, even past existing asset information, into these mapping solutions?
Yeah, so as far as working with surveyors goes, both on the Esri and Colligo side of things, they support all state plane projections practically they could ever think of. And then as far as, once you start doing, measurements, applying scale factors and whatnot, both tools do have different methods to account for that to integrate into your GIS system. Yeah, it's a couple of slight differences between more the GIS side of the world where I'm from and surveying, as I'm learning more and more every day. But they both have ways to account for that.
Thank you, because that's something that comes up, when you're approaching a deadline, right? Or you need the information now, and you gotta have an idea of how you're gonna utilize that. So there's a great question about, can these workflows and tools be expanded into other areas of community service lines?
Yeah, I believe so. I mean, anything with GIS, as far as, I mean, these platforms that we're talking about, Esri, Colligo, that kind of thing, it's not just geared mainly towards GIS or lead service lines. I mean, it can be involved into other utilities or other infrastructure needs, resources, that sort of thing, not even past, say, even past utility. You get into an emergency response, you can get into, again, tax parcel mapping, that sort of thing. So it goes much beyond this topic we're talking about.
So John mentioned that they've contracted gathering this asset inventory out. What other considerations would you all take into account if you were requesting these GIS deliverables from a third-party surveying or engineering firm?
Just speaking from the hardware side of the fence, I would always make sure they include, one datum and projection and everything for the coordinates, whether it's northeast and eastern, lats and longs, but most of all, just metadata as far as at the very least horizontal accuracy, but preferably, which network they're connected to, and just the method of collection and everything. So.
Yes, coordinate systems projections are always good to know. If that can be added initially, I know sometimes if we don't have that information, we have to start searching and guessing and taking a look and see where things fit best. If we're looking at say AutoCAD, old as constructed AutoCAD, again, that's a coordinate system, how to place it. A lot of it is really placement and accuracy is what we're looking for. If a lot of these things can get exported out, if there's any information that can be exported out into a shapefile, that kind of thing, that's always a great help.
Yeah, I would add just ensuring the schema lines up with whoever you're reporting to your primacy agency. But also I wanted to mention that the lead service line inventory solution does allow you to enter your spatial reference ahead of time so that it will deploy in your spatial reference. So that will help there as well.
That's excellent. So what if you are implementing these solutions under a proprietary or restricted security clause? What is it like on the cloud services side for network security and cybersecurity?
For network security, cybersecurity, that is pretty much part of what we get with say our cloud servers kind of thing. That's involved in there. We talk about disaster recovery type thing. That's a lot of this is built into the cloud based, into the cloud server, whether it be AWS or any other kind of thing like that. As far as the platform itself goes, there's some security provided in there also, as far as just access, username access, and just deliverable access. What that kind of thing. What is the link? Make sure it's not public. There's a lot of safeguards involved in that data security portion of it. The cloud-based kind of thing takes a lot of that security issue away from, say, on the on-premise side, where the on-premise servers, whatnot, located inside a DPW city hall type thing where IT is involved. There's a lot of security issues that need to be performed internally.
Excellent. So Jeffrey has a general question that I'll say something about, but I'd like y'all to expand on. So he says, for a growing city that depends on other, more expensive entities to update their city's GIS map, He asked, how can we take charge of being able to update maps and add annexations, incorporate the water, fire, and electric shapefiles that we need, to be able to see on these maps and maybe not rely so much on the others? Well, if your entity that is hosting these maps allows even a separate login for you to be able to share an editable uh, area, right? Polygons, points, shapes. If you have and can work with them on a workflow, then you would be able to have access to add those edits, and then you could have maybe a scheduled update and implementation that could happen, for example, overnight without human intervention, if y'all feel really confident about those updates that have to go through. Do y'all have some input on that as well?
For a growing city, entities to be able to update their city's GIS map, being, again, the question being able to take charge. A lot of that depends, again, internally. There's GIS staff, GIS knowledgeable staff, or sometimes you may have to, say, consult that out into someone that can provide the expertise in GIS, the expertise in being able to deliver those things. We always try to help the end user do it internally. That saves their time and effort and helps build their experience in GIS and their knowledge. But a lot of times they need a starting point, and that's where some of the consulting and the GIS services provider can help them get started to be able to build that infrastructure, build those processes, and get them comfortable with being able to perform that themselves internally.
Yeah, I just like to piggyback on what Gary is saying. Especially with a lot of smaller organizations, the GIS department isn't that substantial. So it's just a matter of ensuring, one, that you have GIS staff, period, and then two, you have the appropriate training and know-how to understand how to update all the data, as well as ensuring you do have editing privileges, for the schema and whatnot. Permissions issues are definitely something we've run into before with smaller organizations attempting to start taking charge and everything. But yeah, with ArcGIS solutions, just with a couple of different areas you mentioned as far as utilities go and starting to track them, there's some pre-made stuff out there that makes it super easy to just to hop on there. Obviously, as we mentioned before, importing the data, implementing the data does take some considerations, can be a little bit of a challenge, but once you get everything implemented and you learn the update process, it makes it so much easier to take charge because the standards and the scheme is already set for you.
And just to clarify, a lot of documentation and schema outlines and whatnot can be found on the help documentation. I know Esri has extensive help documentation, and I'm sure that there's information about Bad Elf's hardware that you can, but also, make sure you stay in connection with your collaborators, with your product providers, so that you can continue these conversations, because really when you get your hands into it, that's when you end up finding out what are your snafus, right? Like, what are you running into? And being open for that collaboration will definitely help you get to your end product a lot easier. And what a great topic today, moving us towards a safer and healthier world with more accurate and precise data about our infrastructure. Does anybody have any last points that they would like to make or share? I know, David, I always adore the Bad Elf artistry, and I love how it also depicted what that process of working in the field was. So thank you very much for sharing that today too.
Yeah, thanks for having me. Yeah, artist is Matt Ryan. Definitely sign up for our newsletter. Check out more of his stuff. It's basically a comic each month, so something a little fun for your inbox.
I'd like to thank everybody I'd like to thank you for allowing us to be part of this today. If there is any more information you can go to colligogis.com. The Esri solutions are very powerful. And again, it depends on what your needs are. You know, the size of your community, again, your staffing availability, that kind of thing. And I'm sure everybody here is available to help. It's just mainly a point of reaching out and trying to contact us and see what we can do to assist.
Yeah, I'd like to thank everybody as well. Definitely check out the lead service line inventory solution, but also our other solutions as well that may address some of your industry needs.
Thank you to our sponsors that made today's event possible through asset mapping and these geospatial virtual events. There are more events, so please make sure you head over to asset mapping events and join us for more. You know, I'm sure that each and every one of our panelists also have webinars and stuff that their companies are putting out. So please make sure to check out all of them as well. And we are so glad that almost 200 people joined us today for this very informative webinar. Thank you, everybody, and we hope you have an excellent day. Oh, if you need this for GISP points, just make sure that you enter in the GISCI your information about today's webinar for those educational credits. So thank you again.